What I have here is a model control circuit that's pretty typical in heating and cooling systems, and you can see I have a little red indicator light here that indicates that I have 24 volts through this wire here. Now right here I have a little bare spot of copper. Now what I'm going to do is I'm going to take this alligator clip, I'm going to clip it onto the metal box here, which could be the chassis of the unit or ductwork, and I'm going to take the other end and clip it right on that bare piece of copper. Now what do you think is going to happen? Now as you can see, absolutely nothing happened. Now if your guess was that this was going to create a short, don't feel so bad. A lot of people would have guessed that. Let's begin by showing you why this didn't create a short circuit and what I do first before I do anything else that sometimes can actually help me narrow the problem down to either one or two components. In worst case scenario, it actually tells me what I should be looking for when I actually begin my testing. Now the first thing I do before I start trying to look for this short is I'm going to come to the transformer and I'm going to figure out whether or not I have what is called a grounded secondary or a floating secondary. Now a visual inspection of this isn't always reliable. Sometimes you might actually see a ground wire coming off the transformer and actually grounding onto a metal surface. But sometimes these transformers are grounded internally. So it's always best to use your multimeter to tell, and to do that, you shut off your power, you disconnect your wires from your transformer, and you do a continuity reading between common and metal chassis. And if you're reading continuity there, you have a grounded secondary. If you read nothing, you have what's called a floating circuit. So what is a floating circuit? Why is that important to know? And how can this help us quickly diagnose where a short might be located? Your entire low voltage control circuit starts with the high voltage coming into your unit, and with that voltage is going to be a ground wire. Now that ground wire is going to connect to the switch itself. It's going to connect to any metal boxes. That ground wire will continue on and connect to any other metal boxes that might be along that circuit, and any other metal touching these boxes is also going to be grounded. So the sheet metal that these boxes are mounted on will also be grounded. In my model here, you can see my contactor has a metal base that is mounted on the sheet metal, so that is also grounded. The metal cover on my zone valve in this model is mounted on the sheet metal, so that is also grounded. So any metal touching metal that is grounded is also going to be grounded. Now a floating secondary has no path between the common on our low voltage circuit and the ground that is going back to the ground on our high voltage circuit. So these are completely separate, and that is why we call it floating. A grounded secondary would essentially be the same thing as me putting alligator clip on the common, clipping to metal, and now I will get a continuity reading on any common point in my low voltage circuit and the metal ground. So I have one probe on my common on a transformer, the other one I could touch metal anywhere and get continuity. Now what all of this essentially means is that we now have a path for 24 volts to lead the load on our transformer, go through the wire. The bare copper on the wire touches metal, which we simulated with our jumper here, and that metal can now connect through back to the common, and that's what creates our short circuit. But when we remove that ability for any voltage on the metal to make it to common, we now have a floating circuit that doesn't blow our fuse. Now let me just demonstrate this to you really quickly, and then we'll go into explaining why this is such a great benefit in finding shorts very quickly. So what I have here is what's called a Short Pro tool. It has a little light on it, and what you do is you connect the alligator clips. And what you do is you connect the alligator clips to where the fuse might go on a control board. So we take our fuse out, we hook our clips up, and if we have a short, there's a little blue light on top of here that will light up, telling us we still have a short. If there's no short, it doesn't light up. Now I'm going to go ahead, I'm going to ground this secondary and keep an eye on our Short Pro tool. As soon as I touch to metal, you can see we now have a short, because now we have a path for that voltage to make its way back to common. Short, no short. Short, no short. Now here's why this is such valuable information to know when you start looking for blown fuses in a circuit. If you know you have a floating circuit and you're still blowing fuses, you now know the culprit is unlikely going to be just a bare wire touching metal, but it's going to be an actual component in your circuit that provides resistance that is no longer providing that resistance. And so what we did by figuring out we have a floating circuit or one that's grounded is that we can almost eliminate half of what the possible problems might actually be. Now, if you have a grounded transformer with a grounded secondary, one thing you can do is disconnect that ground from the metal and actually turn it into a floating circuit. At that point, you can see if the fuse is still blowing, which will tell you whether it's going to be a grounded wire or a bad component. Armed with the knowledge of whether you're dealing with a floated or a ground secondary now allows us to take a second step, which is usually the first step in a lot of these videos, is to go to the thermostat and try changing to different modes to see if our fuse is popping in a particular mode. So what I'm going to do to demonstrate this is we're going to start off with a grounded secondary, and I created a short on our heating wire. That's the white wire coming off the W terminal on our thermostat, and you can see I have a green alligator clip going directly from the bare wire to the metal of our zone valve box here. And as we indicated before, this metal is grounded, and with a grounded secondary we now have a path going back to common. So what I do is you want to put it in cooling mode, and you could see everything works. We have no short here being indicated. We could turn our fan to the on position. Everything's still fine. Turn our fan back off. But once we put it into heating mode, we now have our short. Now on a grounded secondary, this doesn't really tell us whether the short is occurring with a bare wire touching metal or the actual failure of the component itself to provide any resistance. So what I'm going to do now is I'm going to remove the grounding of this secondary and turn it into a floating circuit. I'm going to go ahead, turn my thermostat back into heat mode, and you can see we do not have a blown fuse. So what this is telling me is that my zone valve motor is still providing the resistance this circuit needs to prevent a fuse from being blown. So now I know I'm looking for a bare wire touching metal. Now let's assume the problem wasn't a bare wire touching metal and the problem was with the motor itself. It's no longer providing the resistance we need to prevent a fuse from being blown. So what would happen here is when we turn our power on and we go into heating mode, we immediately have a short and our fuse blows. Now what this tells us is because our secondary is floating, it can't possibly be a wire touching metal that's blowing our fuse, and now we know we have a component in the circuit that is no longer providing the resistance we need to prevent these fuses from being blown. So now I know automatically I'm looking for a component in the heating circuit that usually provides resistance that now is not. Now what all this allows us to do is really kind of narrow things down to whether we're looking for a short in a wire or a short in a component itself. And if we can narrow this down to which mode this is occurring in, we can create a very short list of items that should provide resistance in a circuit that are no longer providing it. So for example, in an air conditioning system, the few things that actually provide resistance in a cooling circuit would be the contactor in the outdoor unit, or maybe the control board or a relay on the control board, and that's about it. Wires, switches, they often don't provide resistance that will prevent a short from occurring. So what we're looking for is an actual component with an ohm reading on it. In a heating circuit, this might be the gas valve, or it can also be the control board or a relay. There really isn't much else. Now this isn't universal. There are some systems where you might have thermistors that do have some resistance to them, but generally speaking, this is a great approach in the beginning that can really narrow the list down. And if you know it's not a component, you know it's a wire, now you know what to look for. Now I watched quite a few videos on how to find low voltage shorts quickly before I even made this one. If I didn't feel like I had something to offer, I wouldn't even bothered. And one of them that really stood out was AC Service Tech LLC. He goes through a process, is pretty methodical on how to find low voltage shorts. Now that is about as complicated as it gets. That's like the worst case scenario, because in a heating circuit, there's a lot of wires going on prior to it getting to like the gas valve, for example. So it's very, very good to know that process. Now what I'm trying to do in this video is try to find a faster way so that you don't have to go through that entire process every single time you're blowing fuses. Sometimes you could do it a little bit quicker than that, and that can kind of help you get through the day a little quicker and home to the family a little sooner. So with that said, I'm going to leave it here. If you found this helpful and it helped things click a little bit, leave a comment, subscribe, whatever. I don't care. Just interact with the video a little bit so YouTube can get this out to more people and they can learn just like you, because that is the goal here, is to get as many people to learn as possible. I appreciate your view. I appreciate you. Thanks for watching.